Hello, and welcome to today's Saratech enablement session. My name is Andrea Hall, and I'm the Customer Relationship Manager at Saratech, and I'll be the host today. Presenting today, we have Grant Sadowski, who is a Senior Solutions Consultant here at Saratech, and he'll be talking to you about making a case for 3D printing. Next slide. Our sessions run about 30 minutes each. They are all recorded and posted to our Saratech YouTube channel, so just make sure you check out our past sessions there. We meet here about twice a month to learn about tips and tricks, new and old features. But our main goal for our customer enablement sessions are to help you get the most out of your technology investment, enable you to build an internal case for new investments in technology, of course, to share knowledge and to build a community. Of course, while we're sharing knowledge and building a community, your questions and comments are welcome. So during the presentation, if you have any questions or comments, please feel free to type them into the questions box over to the right-hand side, and I will kindly interrupt Grant and just let him know during the session. There will also be a little bit of time at the end to ask questions or make comments, so please participate as much as you would like.
Well, thank you very much. I appreciate the, oh, go ahead.
Oh, no, I was going to say, and with that, I'm going to pass it right over to Grant. Thank you.
Well, thank you for the introduction, Andrea, and welcome everybody. I'm glad you're able to join, and Happy New Year to everyone that's able to join us. So, as Andrea said, we're going to be talking today about how to build a case for justifying 3D printing in your business, and we're going to be covering in a little more detail just 3 core steps to that process. So the first is going to be how do you find these applications? How do you find the use cases? Where do you look in the business to start to build that case? And so we're going to go through some of the methodologies as well as discuss some of the specific areas that you can focus on. The next step, I think, is a really important one here. It's developing ROI to secure executive buy-in. So anyone that has tried to go to leadership, say, in your company and look to get an investment, and it doesn't have to be in 3D printing. It could be in a software package that might help you guys out, or some other something that automate something in the business, or any number of things. And anytime you do that, you're going to find that they really want to see the finances behind it and understand what that investment is going to do for the company. So we'll really step through some of the ways that you can do that as well. And then the last one is just associating a compelling success story. So here we're going to show you how some of this can be relatively complex, but we want to help you just kind of boil that down in a one kind of tight sentence or one statement that really encapsulates what this project's able to do and how it really impacts the company in a positive way. And also just wanted to share that these are things, just to reiterate what Andrea said as we go through. If there are questions, feel free to pose those, and certainly afterwards we're open to help out with any of this if there's additional questions or maybe even a specific project someone wants to go through. And so before I really jump in, though, I wanted to go through some of the common roadblocks that as we engage with our clients that we sometimes see. And so we're constantly working on ways to overcome these and help customers overcome these. So one of the first and obvious ones is just cost of equipment. So, maybe there's a possible need and someone goes and takes it to one of the executives and says, hey, I think this could really help the business, and it costs $100,000 or whatever that amount is. That's a significant amount of money. And so that's probably going to be the first level of pushback. And so today we want to just go through some of the areas that you can help really justify that expense and show that it's going to pay for itself. The next one is just lack of clarity on available options. So with the speed that this industry is moving and the various types of technology as well as materials that are available, there's a whole ecosystem out there that can be hard to keep up with. And again, this is an area that Saratech's really on the front line, and I think we've aligned very well with world-class OEMs, in these areas. But we attend a lot of trade shows and read industry publications and whatnot. So point being that I think we can really help guide customers and kind of help keep them apprised of what all is new out in the industry and what the best solution is for you. The third one is just a lot of companies, don't have a fully developed strategy yet for these types of investments. So there's no financial case being made. So kind of like what I was referring to earlier, the question gets posed, well, why should we spend money on this? The fourth one, I think, kind of speaks to culture. Sometimes you're going to have some businesses that really are on the bleeding edge, if you will, and are always looking to invest, and it seems like they always have the latest and greatest, and other companies that are on the opposite side of that and have a culture of we've always done it this way, and they're a little slower to adopt, which is fine. We kind of see both sides and everything in between. So I wanted to stop this for a second. I don't know, Andrew, if they can maybe type this in, but just see if anyone has any, roadblocks or any times that they want to share an example of where they've tried to get an investment, whether it was an additive or software or really anything in the business, and what an example of a roadblock or an objection you may have got from your boss or from leadership.
Yep, I'm keeping an eye on the questions tab and also the chat box. So either one of those, if you, while Grant is speaking, if you can think of any roadblocks that you've come across that he might be able to help you out with, just type them in there and I'll let you know, Grant.
Yeah, perfect. Thank you. So kind of the first step we were alluding to is kind of how to begin to look for use cases and applications. So there's kind of three core paths that you can go down. First one being pain points and cost drivers. So this one's relatively easy. I think a lot of times when you have something in the business that you continue to hear about day after day, week after week or whatnot, that's going to be an example of a pain point. And so that may be something you directly deal with, or it could be something that one of your peers or someone else that you work with, a coworker, might talk to you about. And so going down that path and kind of exploring what that pain point is, why it's coming up, what's causing it, so on and so forth, can be an area. And then just cost drivers. So same kind of thing, but this is something where you may have even found a solution, say, for the pain point, but that solution, albeit it may work, it could be very expensive. So those are two areas to go down. Then there's a variety of factory applications. And this one I'm going to kind of bookmark because we're going to talk and kind of go into that in a little more detail later. And then lead time, supply chain, and production cycle time. So this is really a critical one, especially in larger companies or organizations where they're really building complex products. So we have some aerospace companies that run into this, where they may have 200, 300, 400 steps in a process, say, to build an aircraft. And when you get to step 200, if there's critical parts or tooling or things that are not ready and available when you get to that step, and it slows up the process, it can be very stressful for the people involved. So a lot of times additive manufacturing, otherwise known as 3D printing, can be used to do that more cost effectively, but also produce that part at that point in time in a timely fashion. So instead of being like, oh man, it's to my stage here in the process, and I still have another 2 weeks from one of my suppliers to get this part, I'm holding it up. You might be able to do that with additive manufacturing, that same day. So building a little bit on the pain points and cost drivers, some areas specifically to look into on your factory floor are tooling, jigs and fixtures, manufacturing guides, inspection gauges, and prototypes. And so these are some of the most common ones. There are certainly a lot of others, but these are ones that we really see pretty commonly and also represent some of the low-hanging fruit for you. The second one there is aluminum parts on the floor. So we found that a lot of times, traditionally, companies have made some things out of aluminum parts or had them milled or CNC'd, and that there's new developments in engineering plastics, or parts that are reinforced with carbon fiber, Kevlar, and other composites that can basically have the same components or the same structural integrity that you're looking for, and again, replace those aluminum parts and do it more cost effectively. The second one here is just manufacturing steps that frequently stop or slow production or are expensive to fix. So these can be machining setup, fixturing and positioning, product line optimization. And again, those aren't totally inclusive, but those are some of the ones we see most often. And then just high strength additive manufacturing can be used to quickly produce replacement parts or custom alignment jigs. So these can all be really good, starting points for you to help, build out your additive manufacturing strategy. Once you've identified these areas of focus, the next part we're going to get to is just how to build the ROI projection for your AM strategy. You're going to look at some things like steady state process efficiencies, line changeover and startup inefficiencies, product breakage and waste, unplanned downtime and scenarios. So these are all areas that I think a lot of companies that do any kind of manufacturing, run into. And we found that additive can really help, reduce things in these categories or help complement or speed that up. So, whether it's a time component or a cost component, again, we're finding that additive manufacturing can really, help out in some of these common areas that customers are facing. And so when we did, and this is the second kind of main bullet point we're going to cover today, is just the ROI. So as I alluded to in the beginning of the conversation, this is something that's really important and I think kind of pulls everything together, because you need to go find the applications, obviously. In the end of this, we're going to talk about compelling stories and kind of how to get your message across. But this is really the meat, I think, of what we work with our customers on, and what we find to be effective when driving a decision that's going to help the company is, how do you build that financial case, and how do you make that really a solid case that's, well articulated and justified. And so in doing the ROI, you want to start off with calculating the cost of your printed part, then determine the cost of alternate production, or it could just be the cost of what you're doing today, finding your break-even point, as well as calculating the time savings, and then ultimately getting to the actual ROI. So the ROI is the core of it, but we have a couple other elements to it that I think, really help strengthen. So that first part is calculating the cost of the part. In this case, we just chose a relatively easy part. So this here's a handle for a Ducati, a brake handle for a Ducati motorcycle. And there's a variety of ways that you can get to the, cost analysis. But in this case, we use one of our manufacturers' software called Eiger and put that in there and uploaded that. And ultimately, this particular part would cost $58.83. And it was using the combination of a material called onyx and then reinforced with carbon fiber. So it's really going to mimic some of the strength capabilities of, say, aluminum 6061. And so if you go to the cost of alternative production, this brake lever is normally CNC milled, as I discussed earlier, and costs about $195.95. And so when you compare the two, and you say $195.95 for it to be CNC milled versus $58.83 for it to be printed in carbon fiber and onyx, then ultimately the cost difference is pretty significant there. So that's $137.12. So it's a lot more cost effective. And lastly, as I talked about with the time component, it's always something you want to look at or consider, because sometimes we found additive is dramatically less expensive than maybe a traditional manufacturing method. Other times it's actually pretty similar. And we even have cases, and I'll get to one of these earlier, where additive costs more to make the part, but some of the speed and other advantages of doing it additively actually make sense and still make the business case. So that's why I think it's important to certainly just look at and explore the cost of it, but look at some other areas of impact. And so, as I mentioned, though, this is going to be $137.12 less expensive. So in this case, if you look at the machine cost of around $13,500 divided by the cost difference there, you have 98 and some change. So basically that's saying that after you print 98 parts for this particular example, then you at your break even. So anything above that, you start seeing a return. And then the second, thing I wanted to look at in this example is just the fact that if you have that 3D printer on site and it's now localized as opposed to something that you're outsourcing, you're going to have the quicker turnaround for completed part. You're also going to have faster changes in between parts. So if you go back one here and look at, 2 to 3 week lead time. So let's use the extreme and say it's 3 weeks. If you send that out and you wait 3 weeks to get the part back and there's any issues or challenges, or maybe it's just not done properly, then you got to send that back out again and you're out 6 weeks. And you can see how that could really build up from a time perspective, as opposed to being able to 3D print it and sometimes do another iteration within a day. And so I think that you just see that speed to completion, as well as iterations and optimization, really start to gain some traction and kind of help move through the cycle more quickly. So the last section here is calculating your ROI. So in this particular case, you have an 87.3% return. And so there's, in this example, we kind of look at if there's 3 products that you're going to need to fine tune, and each one might have 3 iterations. That's a total of 9 parts with their own unique molding and machining processes and whatnot. So from only 9 product prototypes in this example, the machine will have paid for itself and returned 87.6% of the cost on top of actually paying for the machine. So it's pretty significant. And this is something I think is really kind of a common example that we run across, where people are surprised when we step through this process with them, how much the return is, as well as how quickly it can happen. And so that kind of brings us to the third and final step of basically developing your additive manufacturing or 3D printing strategy, and how to kind of build a compelling case. And that's associated in a compelling story. So in these examples, I'm going to kind of go through these, but then pull up some other pictures and other examples from these that'll kind of hopefully bring all that home. So the first one is just how $90 can save a $36,000 problem. So we're just going to talk about later how a handle on an assembly part that was really causing problems for a company cost them about $1,200 each, and they were having 30 of those a month. So that's where the $36,000 came from, and how they spent $90 to solve that problem. So one of the stories that I think really will resonate with people. And again, we like to work with our clients to try to uncover and find these in their own business. The next one's a really significant, a really big one, and that's not a typo. So that's basically, working with a company to get a handle on a $400 million problem. And so to kind of dive into this, we have a global company that we're working with more locally at the moment. And in the Texas Gulf Coast area, they have $400 million in MRO inventory. And with that inventory, if you take that down to just one part and say you have a $100 part, after 3 years, you will have paid for that part again in inventory tax. And so you buy the part, pay $100, and year 2, you have your first round of inventory tax, and you have to pay $33.33, and then year 3, year 4, so on and so forth. So by the end of that, you will have paid $100 again. So now when you scale back up and look at how much they have, we're talking about an $800 million problem, and that's only in the Gulf Coast area. Throughout the country, they said they have between 2 and 3 times this. So again, even though this is a very large company, when you start getting up in the hundreds of millions or potentially billions, that's certainly something that's going to catch someone's eye. So we're talking with them about how 3D printing can basically reduce some of that inventory and move them more to a parts on demand model. And as I just alluded to, one of the biggest areas of savings is going to be in the inventory tax area. And then lastly, if you just think about the warehouse space where all this inventory resides, as well as employee payroll, liability, and different things that the company's paying for, you start to get a picture of something that's in the billions of dollars, and not that we can necessarily impact all of that with 3D or additive, but certainly a significant amount of that. It certainly gets some attention and kind of bubbles that up to a high priority within the company. And then the last example here about associated and compelling story, I thought was a pretty cool one, and really interesting, where this was our first meeting with a company called Jail Audio. They make high-end speakers for your home, and they do a lot with the marine industry. And we were meeting with them and decided to go do one of these walks, as we were talking about earlier, just to kind of go explore the floor and see where they have assembly or manufacturing or things going on, and if we couldn't identify a couple areas where additive might be able to help them out. And so in this particular case, on the very first area we went, there was basically an assembly line that had 100 workstations. And so as we started looking at that and asking questions and trying to better understand what they were doing there, one thing that really bubbled up was each one of the assembly areas had basically a machined piece of aluminum that cost $4,000 that they used to put all the wiring through and everything like that for the speaker to put it all together. And ultimately, when you do the math there, that's $400,000 in tooling and fixtures and whatnot, just in this one area. And so as we asked him more questions about it, he told us how every time that they have, a change to the speaker design or something to optimize it, or a new one that comes out, these tools or these fixtures actually need to be replaced. And so you can imagine it's a pretty costly proposition there when they do 3, 4, 5 of these a year. You start looking at $400,000 per. And again, this is just one little area of their business times 4 or 5 different iterations throughout the year. You're talking millions of dollars. And so they were able to replace this with 3D printed parts that still had the same functionality and the same properties they were looking for a fraction of the cost. I think it was around $50 per. So instead of $4,000 per, it was $50. So pretty significant. And so here's one of the specific examples we talked about with the valve handle. And so if you see the one there that's silver, and in the top black portion of that was the part that was breaking, just that top portion. So when this company went and tried to purchase new ones, their vendor would only sell them the full assembly with everything. And they said, well, we just need the top handle, and they would not sell them separately. So that was a difference of $1,200 for the assembly, as opposed to this customer went to their engineering team and came up with a quick design, and they were able to print them for $3. So that's a 99% cost savings, as well as a 92% time savings. So the difference between just 3D printing it that day and waiting upwards of 2 weeks to get a new valve. And as I talked about in one of our last meetings, we asked them, how many times this was happening, and they have plants, again, all over the country. And they said right now it's been 20 to 30 a month. So that's kind of where, and I'll scroll back one, where that $36,000 problem, basically 1,200 of these times 30 is $36,000 a month. And now they're printing them for $3 each, so they can get all those replaced for only $90. So pretty significant again. And I think something that would really resonate with leadership when you talk to them about, these kind of solutions. Some of the takeaways here, the first is that the handle master exceeded the performance of the traditionally injected molded ones. The second one being that the 3D printed valve, delivered a significant ergonomics improvement. So they did make some changes to the actual design just made it easier to kind of turn it, on and off out there in the field. And then the last one is just, in this case, again, you don't have to go to another vendor. You can do this all in-house. And so this is a solution that's ready to integrate today, the same day, throughout the company and the organization. And actually, to that point, even since this originally happened, multiple other markets with this company, they've shared this story, and now they're utilizing this as well. So kind of a cool story and how that worked out. So the pump impeller is this is an example of one that I really like because it's a little different from the other two in that the impeller in this case actually costs more to 3D print. But you're getting an 83% reduction in time as well as a potential savings in the millions. So the reason you get that is with the original one, whenever it failed, it could potentially have an entire plant go down. And when we talked to leadership at this company, they said it depended on what kind of plant, what type or what time of year and a variety of other factors. But ultimately, when one of these failed, it could be anywhere from $3 to $5 million per hour that the company was losing. So as you can imagine, in a case like that, when you're talking, and let's just use, $5 million an hour, 5 hours is $25 million. So, their message to us was, we're not really that worried about how much it costs to 3D print. We're really more worried about the, just the reliability and the structural integrity of the part. And so they were able to basically print these impellers, which actually exceeded the traditionally cast ones. And moreover, the traditional impeller took 1 year to get 100 successful parts, and now they can be delivered in 2 weeks or less. So that's a really big improvement. And they can now do them one-off. So as you see this third point here, they had a minimum order quantity for the impellers traditionally. So if they had one that was broken and they needed to get, or they were required to buy 25 or 50 or 100, that was way more than they needed. Whereas now they can just do it on demand using additive manufacturing. The last one here is just a spray kiln nozzle. This one was previously injection molded with Teflon. So if anyone knows about that process, it's extremely costly. So they were basically able to, again, migrate and move over to 3D printing for this and save about 91% on their cost and 96% on their time. And in this case, some of the takeaways again are that the kiln spray nozzle exceeded the performance of the traditionally injected molded ones. The original part was held in inventory as a safety stock. So now they can use 3D printing, and that allows for the on-demand production. And again, this application is ready to integrate today. So in summary, the three main things that we really talked about were just identifying use cases and applications, some of the methodologies, things to keep top of mind when you're looking around, as well as some of the people to talk to and where to explore, and then the most common applications that are out there. The next one was just the developing the ROI, which I think again is the meat of this, and really an area that is probably the most critical in the process, because if you go to someone in leadership and they probably have a lot of ideas that come their way throughout the day, if you don't have a really well articulated case that's backed up by some financials, you may not really fully get their attention and get their ear. And then the last one that we just covered is those compelling success stories. So instead of going on a long diatribe about where you went to find these applications and so on and so forth, if you can find that and kind of boil that down to really what exactly is happening and how that's impacting the business in a sentence or two, I think you can get someone's attention, and then you can dive into more of this detail and the justification we talked about today. So Andrea, I don't know if you want to.
Awesome. Yeah. If anyone has any questions that you weren't able to ask during the session, now is a good time to go ahead and type them in the questions box over on the right-hand side. It looks like we do have one question from George. What is the best way to get started with additive? Grant.
So that's a really good question. I guess it depends on what your reason is for even exploring it. So I don't know if we can see if there's something that's causing you to look at it, or.
Yeah, I mean, I think on your next slide, I believe it is, you kind of touch on those couple of things that they can kind of do maybe to get started. And I'm sure that you and the team could help them kind of explore those whys and then, how to get started from there.
Yeah, so I think exactly, Andrew. I think kind of to answer your question, George, we'd love to work with, anyone that's on the call today and either set up a phone call or in-person meeting or whatnot, or just, something quick to really understand what your business is and what you're looking to do, and maybe explore some potential applications. And so, yeah, some of the next steps we were wanting to propose is either scheduling a follow-up call with myself or one of our solution consultants here. Like I said, we can do an in-person meeting or a plant tour. And the way that typically works is we do a call actually before that, and then a solutions consultant and an application engineer will come out and just do a quick tour of your facility, and then sit down afterwards and have a meeting and just talk about the observations, what you saw out there in the plant, and step through some of the things that look like low-hanging fruit that we see a lot of times. And then the next step from there is, a lot of times we'll work with our clients to find a few examples that we found out there of use cases or case studies where we can say, hey, here's something you're doing today traditionally, and then looking to basically create an STL file and do a 3D printed benchmark, and then just compare some of the metrics that we talked about today in terms of the time, the cost, so on and so forth. And I did want to add that we do have some white papers and case studies and some other support material that, because today, we had a limited amount of time, so I was trying to get through. We had a lot of information to cover, but some of this certainly has some more detail behind it, and there's different, mathematical formulas and things I didn't want to dive too much into, but we have a lot of support material on that. Again, we're happy to help out. And then I just wanted to encourage anyone that joined today, if you have an example, of a possible use case in your business, shoot me an email. We can kind of take a look at it that way over email. But I think that's mainly what we had, and hopefully it was helpful and educational and informational for everyone. And we look forward to hearing about any next steps we can take or how we might be able to help out more.
Yeah, absolutely. And George, we'll shoot you an email after the session, and maybe you can just start that conversation and see how deep you really want to get into it. And I know Grant and the rest of our team, they're just a wealth of knowledge. So if you just want to ask some questions and see if this is even something you want to explore, then I'll have Grant I'll give him your email address and he can shoot you an email. Grant, we do have another question from Doug. It says, what successful metal printers are on the market today? And by successful, I mean that they deliver what they promise.
Yeah, so there's a number of different metal 3D printers out there, and the costs really range anywhere from $100,000 up to $1 million. It's probably something I'd rather take offline and talk a little bit more about, just because there's so many different options out there, and I don't want to necessarily advocate one over the other or knock on any company. But yeah, I do have some more opinions about that I'd be happy to discuss offline and explore. And part of it too is that it again is kind of application and budget dependent. Because there are a lot of different machines that are effective and do work well. They just do, different things. Some of them do, smaller, more detailed parts, while there's, $1 million plus systems that go through the full, metal process, where there's some automation that happens in there where you can eliminate some of the human element and human cost there that typically needs to happen in that process. But again, that's upwards of $1 million, but everywhere in between. So that's one, if you want to shoot me an email, we can kind of talk through some of those options out there, and I'd be happy to send you some of the spec sheets, pricing, and then just kind of weigh in, as to my opinion, at least, of, which ones are the, most effective, or which are the best value and bang for your buck.
Perfect. And yep, if anyone wasn't able to ask their question or their comment right now, we do send out a little survey as soon as this session ends. You can let us know how we did today. If there's any information that wasn't included in the session today that you'd like to hear more about, you can include that as well. Looks like we do have one more question from Jeff. It says, does Saratech have testing capacity for component structural integrity?
So in terms of the structural integrity, I know that we have a lot of data and information, white papers, et cetera. I actually don't know, and I should, I guess, if we do any of that in-house. I think we do have some simulation software as well where we can do that. So Mikhail Bondarenko, one of our application engineers, a lot of times when I get asked that question, he's kind of my resource for that. So I'd have to check, though, if we have any actual equipment for that. But I do know that we have a ton of information, data, knowledge, and then software that can basically do a variety of different simulations for strength, heat, and a number of other factors. So yes, that is an area we can help out with as well.
Okay, so Jeff, we'll follow up with you after we get the right resources and see if we can team up with you on that and answer whatever questions you may have about the testing.
Yeah, good questions, by the way, too. I think all those are really good.
Yep,
especially
absolutely.
More about testing, because I think that's important as well.
Yep, absolutely. Okay, looks like we may not have any more questions. You want to go to the next slide then? All right. And again, thank you all for attending. We did record this session. We'll be sending out the recording as well as a little bonus material that Grant has that we'll be sending out. So there'll be an attachment as well as a link to the recording, and you are welcome to watch it as many times as you want, and please pass it along to your colleagues and anyone else that might be interested. We are planning on doing a few more additive manufacturing, 3D printing sessions this year. So be on the lookout, and we do take your suggestions very seriously. So if you have suggestions about customer enablement sessions that you would like to hear about, that's why we do them. They're for you all. So please put that in the survey afterwards if you would like to hear about anything specific, and we will do our best to work it into our schedule. And thank you all again so much for joining, and have a wonderful day. Thanks, Grant.
Yeah, thank you, Andrea. Have a good one, guys. Thank you.
Bye-bye.